So this is where we start to transition into fractions into decimals. So to change a fraction to a decimal, basically all we have to do is use division. So 1 divided by 2 means we can go like 2 into 1. And we have a decimal located right at the end there because that's the ones place. And notice since 2 doesn't go into 1, what we do is we add another 0. And since the decimal point's there, I didn't change any value. And then we can just bring the decimal up into the problem. And 2 goes to 10 5 times. And 5 times 2 is 10. So my remainder is 0. So we end up with 0.5 or 0.5. So 1/2 is equivalent to 0.5. One's in fraction form and one's in decimal form. So 3/4 I could change to a decimal by just dividing 4 into 3. But since 4 doesn't go into 3, we put a 0 in there. If we don't know our 4 facts, we can come over and write down 4, 8, 12, 16, 20, 24, 28, 32, and 36. So how many 4s can we get into 30 without going over? And that would be this 28. So again, I bring my decimal point up. 7 goes here. 7 times 4 is 28. We get a remainder of 2. Since I got a remainder of 2, we add another 0. Since this is decimal math, we just keep going. 4 goes to 20 5 times. 5 times 20 is 5 times 4 is 20, and I get a remainder of 0. So that would be then 0.75. And you may already knew that. So that's why I was kind of doing that, because you may already knew that 3/4 was 0.75, but you actually use division to do it. And you can also do that on a calculator if you want. Just type it in as a division problem, it'll change it to a decimal. So some common benchmark fractions that you may be familiar with. 1/10 is the same thing as 0.1. 1/8 is 0.125. 1/5 is the same thing as 0.2. 1/4 is the same thing as 0.25. 1/3 is a weird one. It's 0.33 with a little bar over it, which means the 3 just keeps repeating forever. So it's like 0.333333 on to infinity. So that's what's called a repeating decimal. So a lot of times 1/3 is reduced to just 0.33 as an estimation. 1/2 is the same thing as 0.5, as we mentioned. 3/4 is the same thing as 0.75. 2/3 is the same thing as 0.66. That's another one of these weird ones. It's got a repeating decimal. It's commonly rounded to 0.67 if it's rounded. 2/10 would be just, again, 0.2. 3/8 would be like 0.375. So if you're like a machinist, these are things you would have to know, have to have memorized. And 2/5 would be like 0.4. So that would be some common fractions that if you have those to memory, it's very powerful as you move back and forth between fractions and decimals. So as we said, changing fractions to decimals is basically just division. But to change decimals to fractions, what you need to be familiar with is what's called the place value chart. In the place value chart, we should know that the ones is just to the left of the decimal point. So here's our decimal point. The ones is just to the left of the decimal point. Then we have our tens place, hundreds place, and then thousands place. If we go over here to the other side of the decimal, this is where you get into the fractions and decimals. This is referred to as the tenths place. It's got the little THS on there, tenths place. Means you're dividing by 10. Hundredths place So that means you're dividing by 100. And then this last placeover is going to be the thousandths place. So that means you're dividing by 1,000. So that third placeover is the thousandths place. So if I look at 0.5, we can change this to a fraction rather easily. The denominator is basically the place value of the far right number. Since 5 is the far right number, it's one place past the decimal. And if you're one place past the decimal, that's the tenths place. So 0.5 is the same thing as 5/10. So they read the same way. Both of these read as 5/10. One is a fraction and one's a decimal, but they are equivalent. They're just in different forms. So 0.75, notice how it goes 2 decimal places to the right of the decimal. If you go 2 places to the right decimal, that's the hundredths place. So 75 is the same thing as 75 hundredths. So in other words, you're dividing by 100. So that's 75 hundredths. So these read the same way. That's 75 hundredths and that's 75 hundredths. A lot of times 0.75, we just say the digits. That's not really reading it. So if I look at 0.125, the correct way of reading it would be to say, well, what place value are you in? Since we're the third, the number to the far right is 3 places over, that would be the thousandths place. So that would read as 125 thousandths, or divide by 1,000. So that's what that would look like as a fraction. Now the catch is fractions have to be in lower terms. So notice how 5/10 would reduce down to 1/2, because you can divide the numerator and denominator by 5. Notice that here, the 75 and the 100 can both be divided by 25, and that would give me 3/4. So 75 hundredths is the same thing as 3/4. 125 thousandths, that one's a little trickier. So I do know that I can divide, let's say, I wonder if 125 will go into 1,000. That looks like a lot of work, doesn't it? Let's see if we can just divide a 25 out. If I divide a 25 out, how many 25s go into 125? Well, that would be 25, 50, 75, 100, 100. That's five 25s. So that's going to turn into a 5. So how many 25s kind of get into 1,000? Well, I do know that 25 goes into 100 4 times. So 4 times 25 is going to be 100. So my remainder is 0. So I just got to fill that in with a 0 to hold place value. So that's going to be 40. And then 5/40ths, well, 5 goes to both of those and gives me 1/8. So 125 thousandths reduces down to 1/8. So those are equivalent. So that's a little bit about changing decimals to fractions. You have to understand a little bit about the place value chart. So adding and subtracting decimals. Just like in whole number math, it's all about place values. You want to keep your place values lined up. And the easiest way to add and subtract decimals is just keep the place values aligned by lining up the decimal. So if I have 8 plus 2.5, and again, adding, it's usually down the page. And remember, 8 does have a decimal, it's 8.0. And 2.5, the decimal point's there. So you want to keep your decimals aligned, and then you can add your place values together. So 0 plus 5 is going to be 5. The decimal point comes down. 8 plus 2 is 10, so we have 10.5, or 10 5/10 if I'm reading it using place value. If I have 145 plus 2.35, remember you have to line up the decimal. The decimal on 145 is after the ones place, so it's got to go after the 5. Then you have this 2.35, line up your decimals. And to keep things looking okay, it's okay to put these zeros up here to hold place value, so it doesn't hurt anything. because your decimal point doesn't move, so everything's still in the same spot. So tenths go with tenths, hundredths go with hundredths. So 0 and 5 is just 5. 0 plus 3 is 3. 5 plus 2 is 7. So it's going to be 147.35. So it's important to make that decimal point line up. And if there's not a decimal, make sure you put it in the correct spot. So if I have 11 minus 1.5, remember the decimal is after the ones place, so it's going to be 11.0 minus then 1.5. So keep that decimal aligned to keep the place values aligned. So 0 minus 5 I can't do, so I have to borrow. That turns into a 0. This then becomes a 10. I can't do 0 minus 1, so I got to borrow. That turns into a 0, and then that becomes a 10. So 10 minus 5 is 5, and 10 minus 1 is 9, and you have then 9.5 as your answer. So adding and subtracting decimals, make sure you keep that decimal lined up. So ordering decimals from smallest to largest, just like we were trying to order integers, you had to use money concepts. Money doesn't necessarily apply to decimals because decimals sometimes go past the second decimal place. So what we do with decimal organization, we use zeros if necessary to make all the place values the same, and then we order the decimals. So we want all the numbers to go out to the same number of decimal places. So notice how this goes out past 1, this goes out past 2, this goes out past 1, this goes out past 3. So what I need to do is make everything go out past 3, since that's the furthest to the right. So 5.6, what I do is I put 2 more zeros in. 5.08, I just have to put 1 trailing 0 in to make it go out 3 decimal places. And then I have 5.80. And then I have 5.802. So if I want to arrange them from smallest to largest, notice that the ones place is all the same. Then if you look at the right side decimal, this is like a 600, you have an 80, you have an 80, 800, and an 802. So the 80 looks like that's the smallest, so 5.08 would go first. And then between a 600, an 800, and an 802, the 600 would go next, so the 5.6 would go next. And then, so that takes care of that one, and that takes care of that one. So now we're down to the 800 and the 802. So the 5.800, or in other words, 5.8 would be next. And then the largest would be then the 5.802. So use zeros there to get everything out to the same decimal place, and it helps you kind of see the math a little bit easier. It's almost like whole number math, if you will. You literally could, if you wanted to, ignore the decimal and just see them as whole numbers, and that would also work. Something else that's important is rounding decimals. Remember, if you're rounding, identify the place value that you're rounding to, and you want to use the number to its right to keep it the same or to round up. So if I want to round 1.3815 to the nearest tenth, first I have to identify the tenths place. So here's the ones place, there's the decimal. The tenths place is the 3. And to round, I have to decide what's after the 3, so that's an 8. And we know that if it's between 0 and 4, we keep it the same, and if it's 5 or more, we round up. So that 8 tells me to go ahead and round up. So this turns into 1.4, and then we don't have to write anything else because it said round to the tenths place, so we don't have to put anything else in the problem. We just want to stop at the tenths place. So that would round to 1.4. So if I have 2.8345, if I want to round that to the nearest whole number, nearest whole number means you want to round to the ones place. So identify the place value, which is the ones place, that's a 2. And then we look to the right of it, which again, that 8 is going to tell me to round on up to a 3. So that's going to be then just a 3. If we round to the nearest whole number, there would not be any decimals involved. So that's a little bit about rounding that you probably are already familiar with. So as we move more into decimals, we start to talk about multiplying by 10. So when we multiply by 10, when a decimal is involved, there's a shortcut to that. Remember before, if it's a whole number, if we multiply by 10, we just added a trailing zero. But when decimals are involved, what you actually do is when you multiply by 10, you want to move the decimal one place to the right. And that's going to increase our place value. If you remember, 7 times 10 is 70. Now, since 7 is in the ones place, remember the decimal is just to the right of it. Now, if I multiply by 10, what happens is the 7 point, to get the answer, the shortcut is just slide the decimal to the right one spot. And then all you got to do is fill the spot in with a placeholder of a 0. And therefore, the answer turns into a 70. So if I have like 1.25 times 10, instead of using a calculator, the shortcut is if you're multiplying by 10, all you got to do is slide the decimal one place to the right. So it just falls between the 2 and the 5. So it turns into 12.5. Everything increases in place value. So it turns into that, 12 and 5/10. Now, if you're multiplying by 100, remember 0, 1.25. If I'm multiplying by 100, remember 100 has 2 trailing zeros. That means you're multiplying by 2 tens. Because remember 10 times 10 is 100. Because remember trailing zeros means you're multiplying by tens. So since you're multiplying by 2 tens, that would mean we move the decimal 2 places to the right. And that would also turn into then 12.5 since I'm multiplying by 100. So what we pick up on is there's a shortcut. If you're multiplying by 100, all you really got to do is move the decimal 2 places to the right. So if I have like 0.625 times 100, the shortcut is just slide the decimal 2 places to the right to increase place value. And that gives me then 6.25, a much bigger number. So if I have 5 times 100, you know, if we are using decimals, we just put the decimal underneath. And when you multiply by 10, or multiply by 100, you increase place value by moving the decimal 2 places to the right. And that would give you 500 is when you filled in those 2 spots. And that should also make sense when multiplying by 100. So just a review of that for you. So this takes us to dividing by 10. And dividing by 10 is going to decrease place value. So we have a couple of shortcuts here as well. Dividing by 10, what we're going to do is move the decimal 1 place to the left. That should make sense because remember, division is the inverse of multiplication. So it should do just the opposite of what multiplication does. So if dividing by 100 made the decimal move 2 places, if multiplying by 100 made the decimal move 2 places to the right, then dividing by 100 is going to make the decimal move 2 places to the left. So if I have 25 divided by 10, all I got to do is identify my decimal at the very end, and dividing by 10 means I lose 1 place value. So in other words, I move it to the left, and that turns into 2.5. If I have 25 divided by 100, remember the decimal's on the very end, dividing by 100 means I'm going to lose 2 place values. So I'll move the decimal 2 places to the left. That's going to be then 0.25. So I have 6.4 divided by 10. Since I'm dividing by 10, I'm going to lose 1 place value, so the decimal moves to the left 1 spot. And that turns into 0.64. 85 divided by 100, notice again, you're going to move the decimal 2 places to the left. And that's going to turn into 0.85. 0.3 divided by 10 means I'm going to move the decimal 1 place to the left. So that turns into 0.03. So I lose a place value. So it goes from the 10th place over to the 100th place. That's losing place value. So dividing by 10 is pretty straightforward. You lose 1 place. If you divide by 100, you lose 2 places. So you have to move the decimal to the left. And this takes us to our home stretch. We're now going to talk about multiplying decimals, and then we will talk about dividing decimals, and then you'll be ready for a nice big lunch. So multiplying decimals. One thing to pick up on is, 0.25 is really the same thing as 25 divided by 10 divided by 10. Those are equivalent. Because remember, dividing by 10s make you lose place value, so that takes you back to 0.25. 0.3 is the same thing as 3 divided by 10, because 3 divided by 10 makes you move the decimal one place to the left, so those are equivalent. So those are interchangeable. So if I was multiplying 0.25 times 0.3, what I'm allowed to do is I'm allowed to ignore the decimal and say, hey, that's 25. I'm allowed to ignore the decimal and say that's a 3. But then, since you ignored 3 decimal places, you have to divide by 10, divide by 10, and divide by 10. Because there's 2 numbers to the right of the decimal in the 0.25, and there's 1 number to the right of the decimal in 0.3. So essentially what we do is we just focus on 25 times 3. That would be 75. And then you got to lose 3 place values. So you slide the decimal 1, 2, 3 places over, and you got to fill that in with a 0. So that's going to be 0.075. So there's a little bit of a trick to multiplying decimals. So essentially what we do in our shortcut is we ignore the decimal and multiply like whole numbers. Then we move the decimal to the left by counting the number of digits that were behind the decimal to begin with. So if I want to multiply 0.125 times 0.6, I ignore the decimal and just focus on 125 times 6. So 6 times 5 is 30, carry my 3. 6 times 2 is 12, plus 3 more makes 15. Carry my 1. 6 times 1 is 6, plus 1 more makes 7. And then, how many numbers are behind the decimal? 1, 2, 3, 4. So I have to move the decimal 4 places. So 1, 2, 3, 4. Put my 0 there, and you would still end up with the same answer. I didn't mean to make it that way, but it made the same answer, didn't it? So that would give me 0.075. You could drop that last 0 since it's adding anything to the values. So if I do one more example, if I have, say, 0.3 times 0.4, again, all you have to do is ignore the decimals. 3 times 4 is 12. And then how many numbers are behind the decimal? There's the 3 behind the decimal, and there's the 4 behind the decimal. So there's 2 digits behind the decimal. So that tells me when I come over here, I have to move the decimal 2 places to the left. And so therefore, the answer turns into 0.12. So that's how you multiply decimals. So we're going to now talk a little bit about dividing decimals. Remember, a decimal also has a fraction equivalent. So fraction rules can come into play. So one thing we pick up on is the denominator is really the same thing as like a divisor. So one of our tricks is if I can make the denominator a whole number by moving the decimal to the end, all I got to do is move the decimal the same number of places in the numerator to keep it equivalent. So if I want to do this problem here, I can multiply by 10, in other words, move the decimal 1 place to the right to make the denominator a 5. So if I move the decimal 1 place to the right on the bottom, I must move the decimal 1 place to the right on the top. So that turns into 13.5. So then I can divide 5 into 13.5. So 5 into 13.5. So with decimal division, all you have to do is bring the decimals straight up. 5 goes to 13 twice. 5 times 2 is 10. Subtract my remainders of 3. And just bring down the 5. Don't worry about the decimal because we already have it in the answer up there. So just 5 into 35 would be 7. And 7 times 5 is 35. and my remainder is 0. So that answer would be 2.7. So I really wouldn't need a calculator if I didn't want to. So when I have like this 0.12 divided by 0.06, so my divisor is going to be the 0.06. And I'm dividing the 0.12 by that. And the way this works is you want to make your divisor a whole number, so move the decimal to the very end, which means I got to move this decimal the same number of places. Since I moved this 2 places, I got to move the decimal inside 2 places. You got to mirror that part. So this just turns into 6 into 12. 6 goes into 12 twice, so the answer would just be 2. So that's how division kind of works, is make your divisor a whole number by moving the decimal the number of spaces it needs to make it a whole number, and then mirror that in the numerator the same way. So since I moved the 5, move the decimal 1 place to the right of the 5, I have to move the decimal 1 place in the numerator as well to keep it working the same. And then you can carry on your long division from there.